name is Ka53 Fyp as a first presenter of my group. So today I would like to present about our final year project which is the property brick with gypsum powder and calcium carbonate as an admixture. First of all, I want to say that maybe it's a little bit awkward because we do the presentation by doing the video, but I hope that we can present well to our panels, and I hope that our panels can understand what our final year project about. So I hope that our panels enjoy our video presentation and keep focused. So first of all, I would like to present our first chapter. I would like to say about bricks. Bricks is the building material used to make wall, pavement and other elements in masonry construction. It is composed of a clay, but it is now used to represent a rectangular unit made of clay bearing, soil, sand and lime or concrete materials. There are two basic categories of bricks, which are fire and non-fire bricks. But for our project, we focus on concrete bricks more, which is made from a dry, small aggregate concrete which is formed in a steel mold by vibration and compaction in a static machine. And it is finished by curing rather than fired using low pressure steam. So as our panel can see, this is our slide last sem, but we already edit and do some correction from the last sem. So it's just the same slide last sem presentation. So this is a problem statement, which is the annual cost for repair, maintenance and replacement of civil engineering infrastructure attracts significant attention, and a significant number of existing and new concrete structures suffer from repair and maintenance problems. There are lack of objective construction industries, and it is concerning these problems makes it difficult to establish with any certainty the actual problems encountered in current concrete construction. So this is our problem statement, and our objective for our first, we want to fabricate gypsum powder bricks and calcium carbonate bricks. And our second objective is to evaluate the strength of three types of bricks, which is gypsum powder bricks, calcium carbonate bricks and a normal concrete bricks. And the last one of our objective is to determine setting time, water absorption and workability of the bricks. And next, our scope of study. We focus to do three types. We focus on three types of bricks, which is the sand is present to the normal concrete bricks, gypsum for gypsum concrete bricks and calcium carbonate for the calcium carbonate concrete bricks. And we will test these three bricks by 4 tests, which are strength to measure the strength, and workability, durability, setting time, and water absorption for these three types of bricks. So that's all from me. So I would like to pass to the next presenter to continue our presentation. Thank you.
Good morning to my friends, panel and my FYP supervisor. My name is Tae Ken Yong. Today I'm going to present about the methodology and the result parts of my final year project. So first we have a look at the study flowchart. The systematic way to solve a problem is to do the research methodology. So this table shows the study flowchart based on our research on cement, sand, coarse aggregate, gypsum and calcium carbonate. They are containing 4 main processes, which are identification, screening, eligibility, and included articles. This process helps us to find the good content of articles and suitable for our research. So we look at the first process of our methodology, and it is identification. For our research topic is choosing a suitable material, either sand, gypsum powder, or calcium carbonate, to mix with common concrete mixture for brick, and we will get the best overall bricks from this material. So for our research, the keywords are cement, sand, cross aggregate, gypsum, and calcium carbonate. The total amount of record identified through database Google Scholar searching is 2,788. Number of cements is 582, sand is 481, and coarse aggregate is 712, gypsum is 589, and calcium carbonate is 424. So after we've done the first process, and we move on to the second process. The second process of methodology is screening. This method is used to identify the related and not related articles to our topics. The number of records screened after 11 papers and duplicated is removed, and the number is 250. The number of records excluded on title abstract level is 176, and the reasons are hyperactivity, overlap, and editorial. So for the third process of our methodology is eligibility of article. The suitable and fit article in our research are obtained by this process. The number of full text articles for access eligibility is 112. The number of full text articles excluded is 149, and the reason is hyperactivity, overlap, and no suitable data. For the last process of methodology is included articles. They are the articles which are suitable for the topic, data, and eligibility of articles in our research. The number of studies included in the synthesis is 36, and the number of studies included in the meta-analysis is 11. And now I will present about the result of our final year project. Now we look at this compression strength graph. The y-axis represents the compression strength in megapascal, and calcium carbonate has the highest result in the compression strength test. It has 59.47, 63.07, and 64 megapascal, with 5%, 10%, and 15% calcium carbonate replacement in this concrete respectively. And we have the lowest result, 29 megapascal by normal concrete. And then we have the medium result, 55.5 and 40.5 megapascal, with 8% of gypsum and 11.37% of gypsum used in this experiment. And then we look at the water absorption graph. The water absorption graph, y-axis represents the water absorption with unit percent, and we have the highest result, gypsum concrete. It absorbs most among these concrete bricks. It has 29.29, 30.37, 24.91%, with 25, 30%, and 35% replacement of sand with gypsum in this concrete. And we have the medium result, calcium carbonate concrete, with 13.9, 15.1, and 19.2%, with replacement of 10%, 20%, and 30% of limestone in this concrete. And then we have the lowest result, normal concrete, with 18%. Then we move on to the workability test. We test the workability by running slump tests, and we have the lowest result, normal concrete, 14 mm slump, and the gypsum concrete slump in millimeter is 180 and 139 with increase of gypsum content, which is the highest reading in this test. Besides, the result of workability of calcium carbonate has a medium result compared to the other concrete, which is 113 with 10% of limestone. Then we look at the setting time. The y-axis in the setting time is represent the setting time in minute, and we look at the normal concrete has 30 initial setting time and 600 final setting time, and the gypsum concrete with 1.8% have 115 initial setting time and 150 final setting time, and the gypsum concrete with 2.1% have 130 initial setting time and 165 final setting time. We move on to the next one. The gypsum concrete with 2.4% has 135 initial setting time and 180 final setting time. Now we look at the calcium carbonate concrete. The first one, calcium carbonate concrete with 25% replacement, have 238 initial setting time and 292 final setting time. And the calcium carbonate concrete with 30% have 222 initial setting time and 291 final setting time. The last one is the calcium carbonate with 35% replacement, have 194 setting time and 272 final setting time. That's all for my presentation. Thank you.
Hi, good afternoon to my panel. My name is Sondipo. Now I start present our discussion. So in the table, we can see the tests which are compression strength, water absorption, workability, and setting time. And in the table, we also have name of articles, outdoor, result, and finding. The compression strength of normal concrete is 29 MPa. Water absorption is 80%. Workability is 40 mm with the slump test. Initial setting time is 30 minutes and final setting time is 600 minutes. We use this article and journals from Diploma Materials Utilization Books and Google Scholar. Next is our calcium carbonate concrete. Its compression strength is 59.47, 63.07, and 64 MPa. Water absorption is 30.9%, 50.1%, and 90.2%. The workability is 113 mm in the slump test. The setting time is slightly increased with additions limestone increase. We use this article with similarity 10% to 30% of limestone. And these articles have found from Google Scholar. The gypsum concrete. We found the gypsum with 10% to 30% in the articles. The compression strength is 55.5 and 40.5 MPa. The water absorption is 29.29%, 30.37%, and 24.91%. The workability is 80 and 139 mm in the slump test. The setting time is also slightly increased as the percent of gypsum increase. These articles are found in the Google Scholar. After compare the 4 tests with the result with 3 different concrete, all the articles we are found with all the tests use a few of constant conditions such as time taken of test, 28 days for hardening concrete, and the room temperatures during the experiment. We can know the result as calcium carbonate is the best concrete compared to others in the results. It has high compression strength, medium high water absorption, medium workability, and medium shorter setting time. However, gypsum concrete has shorter setting time compared to normal concrete and calcium carbonate concrete, but lower result with another test. In the conclusion, our objective has been achieved after compare the property and characteristic of normal concrete, calcium carbonate concrete, and gypsum concrete with 4 tests, which are compression strength, water absorption, workability, and setting time of concrete. We choose calcium carbonate concrete is the best concrete to achieve our objective. Our recommendation is the concrete with contain 30% calcium carbonate and some gypsum powder is the best performance because gypsum has shorter setting times to shorter the working time and a lower water absorption to recover the weakness of calcium carbonate concrete. This is our reference to find the article to compare 3 different concrete. That's all about our presentation. Thank you for listening our present.